Okay, looking at question 3, I've just jotted down the key information from the question there. Part A asks for suitable hypotheses. Now, the question says that her belief is that they are not 10. But of course, I've always got to set up my null hypothesis of a belief it being something. I always need the null hypothesis to be equals. So my null hypothesis is I believe it is 10. And the alternative then is that I believe that it's not 10. I also jot down the fact that this is a two-tailed test. That's going to be relevant in a few minutes' time. So there's my hypothesis set up. Part B asks for unbiased estimates of mu, which is x bar, and the unbiased estimate of sigma squared, which is Sn minus 1 squared. So let's do these in turn. X bar, fairly straightforward. Sum of x is over n. I've got that. That turns out to be 9.97. The unbiased estimate for the variance, a little bit more complicated. So various ways of doing this, the way that I like to do it, I first of all calculate the variance, but I know that this is the biased copy. This is the biased version, so I've got Sn squared. So I calculate that, putting in the numbers from the question, and I've got that to be 0.0066. But this is biased. I need to convert it to the unbiased form, which I know has this factor of n upon n minus 1. So I then convert it to be unbiased estimate by timesing by this conversion factor times the biased variance, which is 0.0066 from before, and I've got that calculated out to be 0.0072. So that's the answer to part B. Part C then gets us on to doing the hypothesis test. So the key thing first of all is that the population variance in this question is unknown. So that tells me I'm going to be doing a t-test. As soon as I've got a t-test, and you can do it on your calculator, I'll show you in a moment, but I like to do the calculation so that I know what's going on. I know that the test statistic for a t-test is given by this, and so I can put in the values that I know. I've calculated x bar. The mean, according to the null hypothesis, is 10. Sn minus 1 is square root 0.072, and n is 12. So I've got my test statistic there at this. The first question asks me for the p-value. Now I need to remember that the p-value is asking me for the probability of the observed value or worse. Now I know that it's a t-test, so I've got a t-distribution. I've got n is 12, so I'm using t11. Now my test statistic, that's always centered on 0, minus 1.2247. So the probability of this result or worse will correspond to this area here. And I can calculate that area using TCDF on my calculator. But because this is a two-tailed test, the p-value also needs to include a result being as bad or worse on the other half. So 1.2247, this area contributes towards the p-value as well. So on my calculator, I'll use my calculator to find this area, and then I'll double it, and I'll just check that we get the answer. For that, the p-value should come out to be 0.246. So that's part 1. Part 2 asks us then to make the conclusion, well, the p-value is, in this case, a lot bigger than the significance value of 5%. So p-value is bigger than 0.05, so I accept the null hypothesis. But of course, it asks me to state it in the context of the question. So I've got to say that that means there is evidence to suggest that the mean is 10, because the null hypothesis suggests that the mean is 10. So there's my answer for part 2. And under D, asks me what I've assumed. Now, the assumption we have to make in this case is that the weights of the bags are normally distributed. I've only got a small sample, and so I can't call upon the central limit theorem to tell me that x bar is going to be normally distributed. So I need to know that the weights themselves are normally distributed.